Kshitij, am I audible to you, beta? Kshitij, Kshitij, Sarode, am I audible to you? Kshitij, okay. Now I will share the screen. I will share the screen and then we will start discussing about the experiment. Are you able to see the screen?
Yes, ma'am.
Okay. Just on your unofficial group, just send a message that join it immediately because it is a 2 hours practical. We have to finish it in 1 hour. Immediately after your batch at 11:15, I have another batch, L1 batch. That is why I cannot extend it further. Just tell them to join.
Yes, ma'am.
Kshitish Sarode, please unmute yourself because I can listen to your family members' noise. They are discussing something.
Okay, ma'am.
Okay. Now, including me, 10 are there. How many are supposed to be there? 23 or 24?
24, ma'am.
Okay, tell them, please, if someone is there from your group, etc., just post the message to him or her. Tell them to join immediately. Ameya, please ask everyone to join. Ameya, 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 Ameya Vani, Swapnil.
Yes, ma'am.
Yeah. Tell them to join immediately. Otherwise, 1 hour may not be sufficient. We have to take
Okay, ma'am.
extra. We have to take then extra. We have to finish everything. Chalo fast. Shall we start now? Shall we start now?
Yes, ma'am.
Yes,
Okay,
ma'am.
so
Yes,
last
ma'am.
time, yeah, last time K1 batch was it held last week or not?
No, ma'am.
Mm, why? It was on Friday, that is Shiva Jayanti. Yes.
Yes, ma'am. Yes, ma'am.
Yes.
Okay,
Yes, ma'am.
so we'll plan it after finishing all these 5 experiment. We have 6 turns in our hand, so extra sometimes I will plan it. Today we'll go along with the other batches. That is, we have to determine the hardness of water by EDTA method. What is the long form of EDTA?
Ethylene diamine tetracid acid.
Acid.
Tetrahydrochloric acid.
Okay. Now we have the hard water's definition. The water sample which gives the good lather is a soft water with the soap solution, and the water sample which does not give good lather but gives a curd like precipitate is a hard water. So hardness of water is the soap consuming capacity. Remember all this definition. Hard water is the one which gives curd like precipitate with the soap solution. Soft water is the one which gives good leather with the soap solution, and hardness is the soap consuming capacity. Now we have two types of hardnesses, temporary and permanent hardnesses. Temporary hardness is also, we have done it earlier, that is why I am taking hurriedly. It is a revision for you. So temporary hardness is due to carbonates and bicarbonates of calcium and magnesium, whereas permanent hardness is due to non-carbonate salts of calcium and magnesium. Sodium and potassium salts do not cause hardness anytime. Rather, they are used to remove the hardness of the water sample. So we have the hardness here. If the hardness is between 0 to 75 ppm, it is a soft water. If it is from 75 to 150, it is moderately hard. 150 to 300 is hard, and above 300 it is very hard. We can use the water up to 300, up to 150 positively for the domestic purpose, that is for drinking purpose, bathing purpose, washing the clothes, utensils, etc. So up to 150 it is permissible, but above 150 there are several adverse effects on our body, and therefore the hardness above 150 ppm is not useful for us. Now, what are the adverse effects for domestic purposes? It is that we will get diarrhea or dysentery, vomiting feeling, etc. Main effect will be on our digestive system. And second effect is that if these calcium salts get accumulated in our kidney or bladder, it leads to the kidney stone formation or bladder stone formation, which is nowadays a very big problem. So before using any water, we have to see that water is sufficiently soft so that we can use it for domestic purposes. Now, if as I have said, temporary hardness is due to carbonates and bicarbonates. Carbonates like CaCO3, MgCO3, they are insoluble in water even at room temperature, so you can remove them just by filtration. But the calcium bicarbonate and magnesium bicarbonate, they are soluble in water only at room temperature. So if you boil the water sample, then you get the precipitate of CaCO3, which is removed by filtration. CO2 is a gas which escapes out, and you get what is behind is water. So here also you can write similar reaction, MgCO3 plus H2O plus CO2. MgCO3 is given out, CO2 escapes out, and what is left behind is water. So that is about the theory. Now, what is EDTA? Ethylene diamine tetraacetic acid. So, acetic acid means CH2COOH. If all the four CH2COOH group are there, ethylene diamine. Ethylene means CH2CH2. Diamine means NH2NH2. But here four acetic acid group are there. So, both the hydrogen of this nitrogen and both the hydrogen of this nitrogen, they are replaced by acetic acid group, that is CH2COOH. Now the valency of carbon should be 4, and that is why actually CH3COOH is the acetic acid. But if you will write CH3COOH, the valency will become here 3, then here 4, and here 5. The 3 hydrogen in this way, uh, in the triangular way, one hydrogen, second hydrogen, third hydrogen, then fourth valency will be carbon and fifth valency will be nitrogen. It is not possible, so we have acetic acid is CH2COOH. Now you replace the hydrogen atom from the two acetic acid group by Na, you get disodium salt, which is used for the titration purpose. So the peculiarity of this is that, or why it may be asked, that for peculiarity of it is that it is a good complexing agent. It forms the complexes with indicator as well as the impurity ions present in the water sample. That is why by knowing the amount of complexes formed, you can determine the hardness of water. I'll repeat again. This is the disodium salt of EDTA. 2H are replaced by Na, so it is a disodium salt. You should know the structure of this for your MCQ type of question for your theory examination. Now it is a good complexing agent. It forms the complexes with the calcium and magnesium ion, as well as it forms the complexes with the uh, indicator, and therefore it is by knowing the amount of complexes formed, you can find out the hardness of water sample. Now this is the acetate to NaR there. This is the particular structure of the salt with the EDTA. This is the particular structure of the salt, EDTA salt complex, which is formed with the Ca plus 2 ions. This is the structure. Now what is the principle? The metallic ions are there which causes the hardness are calcium and magnesium, not the sodium and potassium. Again and again I am telling you, calcium and magnesium ion causes the hardness. So calcium, you know that charge is +2, magnesium also you know that charge is +2. HIN is your indicator, which is the areochrome black tea. Remember, areochrome black tea. It is written as areochrome black and T is written capital T, and it is indicated by formula HIN -2. M plus 2 and HIN -2, they will combine to give you the metal indicator complex, which is wine red in color. Imagine that you are doing the titration in the lab. In the conical flask, you have taken the water sample. You have added 2 drops of the areochrome black tea indicator. So areochrome black tea indicator will react with the metal ion present in the water sample, and it forms metal indicator complexes which are wine red in color. म्हणून जेव्हा EBT टाकतो तेव्हा लगेचच तुम्हाला wine red color मिळतो. It is because of formation of metal indicator complexes. तर हा अनस्टेबल आहे, इट इज शॉर्ट लिव्ड अँड अनस्टेबल. म्हणून जेव्हा वाईन रेड कलर येतो तेव्हा लगेच आपल्याला EDTA. Okay, so here M plus 2 are either Ca plus 2 or Mg plus 2. HIN plus 2 minus 2 indicate the indicator. Here the indicator is areochrome black tea. You have to write it like this, areochrome black tea. Can you see here areochrome black tea? In short, it is denoted by HIN -2, M plus 2 and HIN -2. They will combine to give you this particular product, which is called as metal indicator complex. This metal indicator complex is short-lived. It is stable only for a few seconds, and it is wine red in color. So as soon as you get this indicator, you have to add EDTA from the burette. This is the EDTA and this is your metal ion indicator complex. So EDTA will now react with your metal ion and the indicator is recovered during the titration. Try to understand that after adding EDTA, EDTA is more powerful than the indicator. So it will remove the indicator and indicator is sky blue in color. Therefore, the end point is wine red to sky blue. Now you will ask me what is the color of metal ion EDTA complex. So the color of metal ion indicator complex, it is colorless. It is colorless, but since this indicator is recovered during the titration, the end point of the titration is wine red to sky blue. Again, understand metal ion first form the complexes with the indicator. They are short-lived and they are wine red. So you have to add the EDTA. We have seen the structure of EDTA. You have to add EDTA. EDTA being more reactive, it will react with the metal ion and it will throw out the indicator. So indicator is recovered during the titration. See the formula of indicator. It is thrown out, recovered during the titration, and it is sky blue. But this is colorless and longer lived. It is stable for a longer period. So in the examination, theory examination, it may be asked what is the nature of the complexes which are formed with the indicator. So what will be your explanation? Yes. What is the nature of metal ion indicator complex? What will be your answer? Chalo, speak out. Chalo, speak out.
Colorless.
Metal ion indicator. Indicator. Is it colorless? You can
Wine
see
red.
Wine red.
wine
Wine red.
red and they are
Wine
Wine
short-lived.
red.
red color.
They are
Unstable.
short-lived. Short-lived means stable only for a short period. And what is the nature with the metal ion EDTA complex? They are colorless
Colorless.
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 and they are longer lived, stable for a longer period.
Table.
But why the color is wine red to sky blue for titration? Because initially you get metal ion indicator complexes which are wine red in color. Later on, when you add EDTA, you get metal ion EDTA complex, but with the recovery of indicator. Indicator is blue, and therefore the end point is wine red to sky blue. Have you understood the principle? Yes. Have you
Yes,
understood?
ma'am.
Okay.
Yes, ma'am.
Now, what is the procedure? There are three parts. First, you have to find out what is the normality or concentration of EDTA. EDTA, we have total 8 division having same module. So 8 division means 24 batches. That means we have to use the EDTA which is prepared on Monday till Saturday evening. So once it is prepared, we are making it in bulk, maybe 25 liter, 30 liter, etc. So the concentration of EDTA when it is freshly prepared does not remain the same when it is to be used on Saturday for last batch. And that is why every time when you are doing using the EDTA, first you have to find out what is the concentration of EDTA. And that process is called as standardization of EDTA solution. Have you understood or no? Why it is necessary standardization? Yes. Why standardization of EDT is necessary? Am I going little fast? Am I going little fast?
No,
Yes.
ma'am.
Okay.
No,
So
ma'am.
EDTA total we have 24 batches. When it is offline, we have 24 batches. So all batches starts from Monday morning to Saturday evening. So if the solution is prepared on Monday morning, the same solution, if we have to use it for the batch in the Saturday evening batch, the concentration is not the same which was prepared. And therefore, every time when the batch will perform the experiment, we'll check the concentration of EDTA because the EDTA is going to determine how much hardness is there with the water. So it is supposed to be 0.01 molar concentration when it is freshly prepared. It is supposed to be 0.01 molar. But many a times you do not get 0.01 molar. So how to check it? That is called as the standardization. So you have to prepare the zinc sulfate. We are not doing the offline experiment, so just learn the procedure how to prepare the zinc sulfate. So we have to dissolve 0.718 gram of the zinc sulfate powder. You have to take it in a beaker, put little water, dissolve that powder, and then make it 250 in the volumetric flask. Make it to 250 in a volumetric flask. Your 0.01 molar zinc sulfate is ready. So now, uh, have you got the procedure how to prepare the zinc sulfate 0.01 molar? Yes.
Yes, ma'am.
Now, why not everyone saying yes? Any query?
Yes.
Yes,
Yes,
sir.
ma'am.
So you have to take
Yes, sir.
0.718 gram on a weighing balance. You have to weigh zinc sulfate powder. You have to dissolve it in little amount of water in a beaker, and this washing you have to transfer it to the volumetric flask. And volumetric flask, it is of 250 ml capacity. Next time I will try to show the volumetric flask if it is not known to you, or the PPT, whatever, video, whatever I have shared. If you have seen, you will come to know what is the volumetric flask there. Please, if the time permits, someone run that video for 5 minutes so that I'll explain everything there. I'll give the right of the host to someone. So here zinc sulfate is prepared. Now you have to take two burette, burette A and burette B. Always burette A, you have to fill it with EDTA. So you have to take the EDTA which is prepared in the burette, 25 ml burette, and zinc sulfate you have to take in burette B. And then from burette B, you have to take 5 ml of zinc sulfate in a conical flask, add 2 to 3 ml of buffer solution, and 2 to 3 drops of indicator. What is our indicator? Who is our indicator? Who is our indicator? Who is our indicator?
Heliochrome black tea.
Back tea.
Spandan, Spandan beta.
EBT.
Please stop the voice, background voice. Please mute yourself. Please mute yourself. No background music should be there. I am getting disturbed. Spandan, please, no background music. Ask your parents to observe the silence. Mute yourself. Hmm? So we have the EBT, area chrome black tea indicator. We have in A burette, EDTA solution. In B burette, you have to take zinc sulfate. You will ask me why not pipette for taking out 5 ml of zinc sulfate. This is because pipette are less reliable, less standard. So with burette, you have to take 5 ml of the zinc sulfate solution in a conical flask. You have to add 3 ml of buffer solution. This buffer solution, again question may be there in the theory examination. This buffer is alkaline buffer which is made up of NH4Cl, NH4OH. So you have to add the buffer solution which is alkaline, which will maintain the pH of water 10 in alkaline range. Now where if the hardness is there in the water, the H plus ion concentration is more and therefore pH is less. For water sample, the pH is less, and therefore to increase the pH, we are using the alkaline buffer, which is made up of NH4Cl, NH4OH, ammonium chloride, ammonium hydroxide. Then you have to add 2 to 3 drops of Areochrome black tea indicator. All this you will take in conical flask. 5 ml zinc sulfate, 3 ml buffer solution, and 2 to 3 drops of Areochrome black tea indicator. Then go on adding EDTA till you get the color change. What is the color change at the end point? What is the end point of the titration?
Sky blue.
Wine
Blue
red to
color.
wine
Steel blue.
sky blue. Wine red to sky blue. Huh? Why wine red color is there initially? Due to what you get the wine red color?
Heliochrome
Metal
black tea.
EBT.
Heliochrome black tea.
Black tea.
It forms the complexes with metal which are wine red in color. Why you get the sky blue color at the end? Because EDTA forms the
EBT.
complexes which are colorless, but the indicator is recovered during the titration, hence the end point is wine red to sky blue. Have you got it? And you note down the reading. This way, you have to carry out the 3 readings. Every time you have to wash the conical flask, take 5 ml zinc sulfate, 3 ml buffer solution, 2 drops of indicator, fill the burette up to the mark by EDT. Every time you have to fill it up to the 0 mark, and then go on adding and note down the reading. Take the, suppose 3 readings are your 5.2, 5.4, 5.2. So what is the mean of these three? 5.2, suppose 5, 5.2 and 5.4, so that it will become easier for you. Is एक रीडिंग तुम्हाला ब्युरेट रीडिंग मिळाले. वन रीडिंग इज 5 ml, second is 5.2 and third is 5.4. 3 reading you have to take. Every time you have to wash the conical flask, withdraw 5 ml of zinc sulfate, add 3 ml buffer solution and 2 drops of Aerochrome black tea indicator, and titrate it with EDTA solution till the color changes wine red to sky blue. In this way, you have to carry out three titrations. So you will get 3 readings. Suppose one is 5, second reading is burette reading is 5.2, third is 5.4. So what is the mean?
5.2.
Yeah, 5.
0.2.
Yeah, 5.2. So this is your x3 ml, xml reading. So first part, in which you are going to determine the hardness of EDTA, your mean burette reading is xml, which is 5 ml suppose. Now immediately I will explain the calculation so that you will understand. So for standardization in the burette A, we had a EDTA. In burette B, we took the zinc sulfate. Aerochrome black tea was your indicator and end point was wine red to sky blue. These are the reaction. Already we have seen metal ion gives metal ion indicator complex, which is short-lived, and wine red. When EDTA is added, EDTA forms the complexes which are more longer lived and they are more stable. But they are colorless, but indicator is recovered, so you get the color change from wine red to sky blue. Now here 3 readings are there. Write it down in rough for observation table for part this standardization. Standardization. First is your 5, second is 5.2, third is 5.4. So what is mean? What is mean?
5.2.
5.2.
5.2. So I have already sent it to your group yesterday. So you have it. Otherwise, just take the screenshot and write down the reading 5.2, 5, 5.2, 5.4. Then this is your XML. Now you have to use the formula M1V1 is equal to M2V2. Zinc sulfate is the reference solution whose concentration is known to us, which is 0.01. So 0.01, how much zinc sulfate we have taken in the conical flask? 5 ml. Are you getting me? Yes.
Yes, ma'am. Yes, ma'am.
Zinc sulfate we have prepared, its concentration is 0.01. We took 5 ml in the conical flask. So we have Na2EDTA, we have to find out what is the concentration when you are performing the experiment. So M2 into V2, X is your 5.2. So M2, you have to find out molarity of EDTA is equal to 0.01 into 5 divided by 5.2. How much is the answer? Just calculate, give me the answer. Chalo fast. What is the answer? 0.01 into 5 divided by 5.2. What is the answer?
Not one.
0.0096.
How much is the answer?
0.0096.
96, yes.
Okay, we wanted 0.01. See, 0.0096. So your reading is 0.0096 molar. Clear? Calculation, observation table, principle, and procedure. For first part, is it clear? Chalo, speak out. Is it clear everything
Yes,
up to
ma'am.
this?
Yes, ma'am.
Okay.
Yes,
Now,
ma'am.
now second part is we have to find out total hardness of the sample. The water sample which is given to you, not boiled, not boiled. you have to find out what is the hardness of that. The water sample which you will take from the source of which hardness is to be determined, it is not boiled, so it will have the total hardness. So we will, instead of zinc sulfate, now in burette B we will take water sample whose hardness is to be determined. All the time in burette A we will take EDTA. All the time in burette we will take EDTA, and B we will take the water sample instead of zinc sulfate, because we have to find out the total hardness of the sample. Total hardness means without boiling. After boiling, which hardness do you get? After boiling the water, which hardness? Huh? Permanent. Permanent. So now we want first total hardness. So that water sample you take in burette B, A you take EDTA, and in the same manner you carry out the titration. You take 5 ml of the water sample, 3 ml of buffer. Buffer is made up of what? Buffer is made up of what? Yes. Buffer is made up of what? Is it acidic buffer or alkaline?
Neutral.
Alkaline.
Alkaline buffer.
Alkaline made up of NH4Cl, NH4OH. Please pay attention. We are not going to here perform this experiment because of this situation. So remember that we are going to use the alkaline buffer. Again, I am repeating, which is made up of NH4Cl, NH4OH. Because if the water is hard, then the H plus ion concentration is very high. So pH of the water is less. We want alkaline pH. For that purpose, we are using alkaline buffer, which is made up of NH4Cl, NH4OH to maintain pH 10. Then 2 drops of aerochrome black tea indicator, and go on adding EDTA till you get the color change. Again, same wine red to sky blue. Why wine red color? Why wine red color?
metal indicator form.
Metal indicator complexes which are wine red color. And why sky blue color at the end?
Metal ion EDTA solution.
Complexes, they are colorless, but indicator is recovered. That is why wine red to sky blue. Now in this way you have to take again 3 reading. Every time you have to wash the conical flask, take 5 ml of the water sample, fill the burette again with the EDTA up to the mark, and in the conical flask along with the water sample, 3 ml buffer solution, 2 drops of indicator, and go on adding EDTA till the color changes wine red to sky blue. Take 3 readings, find out the mean of that. Suppose it is 3, 3.2, 3.4. What is the mean of this?
3.2.
3.2. So your YML is 3.2. We have 3 readings, 3, 3.2, 3.4. So Y is 3.2. Are you with me? Yes? Yes?
Yes, ma'am.
Okay. Now we will see the calculation for this part. Now this is for the total hardness. Here the reaction are there: metal ion indicator complex wine red color, then with EDTA colorless complex with the recovery of the indicator. Here we have 3, 3.2, 3.4. So mean is 3.2 ml. Now we will do the calculation. This equation we have to take it because it is experimentally proved. We are not going to give any explanation for that. So if you take 1 mole of EDTA, its reactivity is equal to 1 mole of Ca plus 2 or Mg plus 2 impurity, which is nothing but 1 mole of Ca plus 2 or 1 mole of Mg plus 2 is nothing but 1 mole of CaCO3 equivalent hardness. You have seen this in theory. What is CaCO3 equivalent hardness? So we will not go into the detail. So 1 mole of EDTA is 100 gram. 1 mole of CaCO3 is nothing but the molecular weight of CaCO3, which is 100 gram. So 1 mole of EDTA is equal to 100 gram of. This is the practical observation. This is the proved observation. From that, we are doing the next calculation. So 1 mole is nothing but 100 gram, where 100 is the molecular weight. How much is the atomic weight of calcium? How much is the atomic weight of calcium? Yes, 40. 40. Carbon 12 and oxygen 16. CaCO3, you will get 100. So 1 mole of EDTA is 100 gram of CaCO3. So 1000 ml 1 molar. 1000 ml 1 molar EDTA will be equivalent. 1 mole is nothing but 1 ml 1 liter. 1 molar 1 liter. 1 liter means 1000 ml. 1 mole means nothing but 1 liter 1 molar. So it equal to 100 gram of CaCO3. So if the 1000 ml 1 molar is equivalent to 100 gram of CaCO3, so 1 ml instead of 1000 we have make it 1 molar, and instead of 1 molar we have made it 0.01, will be equivalent to what? 100 gram means here you convert it into milligram by multiplying it by 10 raised to 3. So you will get 10 raised to 5 milligram here. Are you with me? This
Yes,
is
ma'am.
milligram. So if
Yes,
you
ma'am.
convert this 100, you multiply it by 10 raised to 3, you will get 10 raised to 5 milligram. So here we have divided by 1000. So here also we will divide it by 1000. So again 10 raised to 5. So 3 zeros will go. Again here it will come 100. Here it was 0.1. We have made it 0.01. So we have divided 1 molar by 100 ml. So here also 100 we have to divide by 1. So you get 1 milligram. Raise your hand if you have not understood. Raise your hand if you have not understood this calculation. Have you understood this calculation?
Yes, ma'am.
Say
Yes,
something.
ma'am.
Okay. 1 mole is nothing but 1 molar of 1 liter. That is 100 gram, because 100 is the molecular weight. 1 mole of CaCO3 means 100 gram of CaCO3. The 1000 gram we have made it 1. 1 का we have made it 0.01. तो 100 का ग्राम कितना बनेगा? 100 into 10 raised to 3. So 10 raised to 5. हाँ? So here we have divided by 1000. So 10 raised to 5 का divide by 1000, you will get 10 raised to 2. And here 1 molar we have divided by 100. So 10 raised to 2 divided by 100 will become 1 milligram of CaCO3. Clear?
Yes, ma'am.
Not everyone saying yes. Yes,
Yes,
or
ma'am.
no?
Why did we divide by 100?
पहले क्या है? 1 mole of EDTA is what? 1 molar. 1 mole means what? 1 liter 1 molar. Huh? 1 mole of EDTA is nothing but 1 molar 1 liter. 1 liter means 1000 ml. And 1 mole of CaCO3, the weight of 1 mole of CaCO3 is 100 gram. Have you understood up to this? Yes?
Yes, ma'am.
Okay. So 1 liter means 1000 ml. 1 molar. 1 mole means 1 liter, 1 molar. So here it is 100 gram. We have divided this by 1000. 100 gram means how many milligram? How many milligram?
100 into 10 power
10 raised to 5.
10 power 5.
5.
5.
10 power
तो यहाँ पे हमने 1000 से डिवाइड किया, इधर हमने 1000 से डिवाइड किया. 10 raised to 5 divided by 1000. How much you will get?
10 power 2.
10 power 2.
10 power 2 means 100, isn't it? Yes or no?
Yes,
Yes,
ma'am.
ma'am.
मिलीग्राम. यहाँ पे 1 मोलर है, यहाँ पे हमने 0.01 किया, तो किससे डिवाइड किया? How you got 0.01 from 1? By dividing by
Divide by
100.
100.
So again for this 100 milligram we'll divide by 100. So how much you will get? 1 milligram. Sure?
Okay,
Yes or
ma'am.
no?
Yes, ma'am.
Yes, ma'am.
Okay,
Yes,
so what
ma'am.
is our burette reading here? 3.2. I gave you the reading 3, 3.2, 3.4. So mean is 3.2. So 3.2. And what is the molarity here? Just now you told me 0.00696. Isn't it? What is this value?
0.09.
0.09. So Y ml M2 molar. Y is your 3.2, M2 is your 0.0096. So you multiply 3.2 into 0.096 into 100 divided by 1000, you will get a milligram of CaCO3. This is present. How much water sample you have taken for titration? How much water sample you have taken for titration? कितना लिया पानी आपने कोनिकल फ्लास्क में?
5 ml.
5 ml. तो ये जो a मिलीग्राम हार्डनेस है वो कितने ml पानी में है? 5 ml पानी में. Are you getting this? So whatever you get the answer here, suppose it is a milligram of CaCO3 equivalent hardness, it is present in 5 ml. Now if we want per liter, that is 1000 ml. So 5 ml के लिए a milligram. So 1000 ml के लिए 200 a milligram. Clear? Clear? Or no?
Yes, ma'am.
Yes.
You want me to explain again all these things? Don't feel awkward. If you have not understood, tell me, I will explain again and again. Please feel free, my friends. Please feel free.
Ma'am, can you send this PDF?
I have already sent it to your WhatsApp group, K Division WhatsApp group yesterday itself. I have already sent this to you, your WhatsApp group. If you want it again, I will send it today. Huh? Have you understood this calculation or no? Okay. Okay, 1 mole EDTA means 1 mole of Ca plus 2 impurity or 1 mole of Mg plus 2 impurity. These impurities, you know that we have to determine in terms of CaCO3 equivalent, because CaCO3 molecular weight is 100, multiplying by 100 or dividing by 100 becomes easier. So don't pay much attention to this. So 1 mole, first this we have dropped it. So immediately we have 1 mole of EDTA is equal to 100 gram of CaCO3. From where this 100 is there? What is 100? What is 100? 100 is nothing but 1 mole of CaCO3. Huh? Weight of 1 mole of CaCO3 is 100 gram. What is 100? What is 100?
Weight of 1 mole of CaCO3.
Okay. Now what is 1 mole but? 1 mole means 1 molar, 1 liter. 1 liter means how many ml? 1 liter means how many ml?
1000 ml.
1000 ml. So 1 mole of EDTA is nothing but 1 molar, 1 liter EDTA. 1 molar, 1 liter EDTA. So it is equivalent to 100 gram. Have you understood this step? What is 1 mole
Yes,
of EDTA? What is 1 mole of
1
EDTA?
mole. 1 molar, 1 liter.
1 molar, 1 liter. 1 liter means how many ml? How many ml? 1000 ml.
1000 ml.
I want the answer from everyone. So now we want for 1 ml. Instead of 1000, we want for 1 ml. So we have divided this by 1000 here. And this gram, we have to convert it in milligram. So how many milligram it will be? 100 into 10 raised to 3.
-3.
Not -3. Milligram means more. 1000 milligram is 1 gram.
Yes, ma'am. Yes.
So 10 raised to plus 3. So 10 raised to plus 2 into 10 raised to plus 3. How much it is?
10 raised to 5.
10 raised to 5. तो यहाँ पे हमने डिवाइड किया 1000 से 10 raised to 3 से. So 10 raised to 5 को 1000 से डिवाइड करो. क्या रहेगा पीछे? 10 raised to 5 divided by 1000. How much it will be? 100. But here it is gram. Now here it is milligram. Are you with me, everyone?
Yes.
Yes, ma'am.
Okay, so 1 ml, 0.1 ml, 1 molar is 1 milligram. Now instead of 1 molar, we want 0.01. How we got 0.01? by dividing by
Divide by
100.
100.
100 यहाँ पे 100 से डिवाइड किया है, वापस इधर 100 से डिवाइड किया, 100 मिलीग्राम को 100 से डिवाइड किया, तो आंसर क्या आया?
1 milligram of
CaCO3.
आया क्या समझ में? So this is the equation. Since 1 ml 0.01 molar EDTA is equivalent to 1 milligram of CaCO3, so y ml is this reading, total hardness ka reading, which I told you 3 ml, 3.2 and 3.4. So the mean is 3.2. So y is your 3.2. What is the molarity? You told me this answer 0.096. Do you remember this
Yes.
answer?
Yes, yes.
I want everyone to speak out. I want everyone to speak out. What is M2? Girls, any girl? What is M2? Molarity of EDTA by standardization. Any girl? Molarity किती आली आपल्याला? By this calculation, how much molarity we got? Huh? How much molarity we got here?
0.0.
Girls, I want the answer from any girl.
0.096.
हा, लक्षात राहिले का सगळ्यांच्या? हा, be attentive. Please don't physically attend the things because we do not have time to conduct this in the lab if this situation continues. So y is your how much? Y is how much, girls? Y is how much here? Mean, I told you. Y is how much? Y is how much? What is the burette reading? 3.2. And what is M2? What is M2?
0.096.
So 3.2 into 0.06 into 1 divided by 0.01. You get a milligram. Find out how much is the value of a milligram. Chalo. 3.2 into 0.096 into 1 divided by 0.01. Find out how many milligram you get. You call it as capital A milligram. Tell me fatafat. Tell me fatafat. Tell me fatafat. No one is doing calculation. Do it. We have very less time. Chalo.
3.2.
3.2 milligram. Are you getting same, everyone? Are you getting same? It may not be 3.2 because here it is 0.096. So it will be something different. If it was 0.01 here, 0.001 here, then 3.2 is correct. 3.2 into 0.096 into 1 divided by 0.01. Do it fast. How much it is? Simple calculation it is. Simple calculation. Please be with me.
30.7.
3.7.
3.072.
So 3.752. What? 752, na? Or 572?
72.
3.2. Okay, so 3.5. 3.
72.
Okay, 72. It is present in how many ml of water sample? How much water you have taken for titration?
5 ml.
5 ml
ml.
में 5 ml में 3.72. तो 1 लीटर में कितना? So you multiply it by 200. 5 का 200 is 1000. So A का 200 is your final answer. 3.72 into 200. Calculate how much it is.
744.
कितना?
744. Yes.
372.
Do it properly. 3.7.
744.
कितना? 744.
44.
This is your total hardness. What is your total hardness? 744 is your total hardness. See all the calculation, understand. Same calculation we have to do for permanent hardness. What is your YML?
3.2.
What is your M2 molar? What is the molarity of EDTA by standardization?
0.092.
0.092.
So what is the value of A? What is the value of A?
3.72.
Okay. So 3.72 into 200. How much it is?
744.
44.
744. Each your which hardness?
Permanent hardness.
Yeah. Have we
Total
boiled the
hardness.
water? Have
Sorry,
we
sorry.
boiled the
Total
water?
hardness.
No. Without boiling
No,
is
no.
total hardness. Without boiling is total hardness.
Total hardness.
Have I made you clear up till now? Have I made you clear up till now?
Yes.
Yes
ma'am,
or
yes.
no?
Yes.
Girls, I am getting less response from girls. Say everyone unanimously, yes. Say everyone together, yes. Okay. Now what we have to do? The water sample. Next part is there. We have seen, first we have seen what is the hardness of EDTA by standardization. Then we have seen total hardness. Now the same water sample, tap water or the same source water sample, you boil it. Which hardness is removed? Which hardness is removed by boiling? Temporary. So which hardness will remain with this water? Temporary is removed. So which hardness remains? Permanent. Here it is total. Now here it is permanent. Same procedure. After boiling the above water sample for 10 to 15 minutes, you cool it and take 5 ml of that. In burette A, always you have to take EDTA. And in burette B, first part you took zinc sulfate. Second part you took the water sample. Third part also you have to took the water sample which is cooled after the boiling. Then add 3 ml of buffer. Buffer made up of what? Buffer made up of what?
NH4Cl, NH4OH.
NH4Cl and NH4OH.
Is it acidic or alkaline? Is it acidic or
Alkaline.
Alkaline.
What is the pH? The pH of buffer? 10. Huh? Okay, and 2 to 3 drops of indicator. Which is our indicator? Which is our
Black.
Areochrome black tea indicator.
Black tea.
Okay, so again you carry out the titration and 3 times 5 ml the water which is cooled, boiled water which is cooled, 3 ml buffer and 2 drops of Areochrome black tea indicator. Fill the burette with EDTA. Go on adding till you get the endpoint wine red to sky blue. Take the 3 reading. Now will it be total hardness reading will be greater or permanent hardness reading will be greater? General knowledge question.
Total hardness.
So here we got 3, 3.2, 3.4. Here you assume that it is 1.5, 1.7, 1.9. You are not performing, so whatever reading I am giving, you have to take them as it is. 1.5, 1.7, 1.9, 3. So what is the mean of this?
1.7.
1.7. 1.7 is your ZML. ZML. Now the calculation, standardization you have done. This you have done for the total hardness. You have done now to find out the permanent hardness. Burette you have taken as usual. Burette A you have taken EDTA. Then you have taken burette B, water which is boiled and filtered. Indicator Areochrome black tea. Endpoint wine red to sky blue. This reaction are same. Now here 1.5, 1.7, 1.9. So here 1.7. Your burette reading is 1.7. Now again same. 1 molar EDTA is 1 mole of Ca or Mg equivalent hardness, which is equal to 1 mole of CaSO3. But 1 mole of CaSO3 is nothing but 100 gram. So 1 mole of EDTA is equal to 100 gram of CaSO3. Now what is 1 mole? It is 1 molar 1 liter. 1 molar, 1 liter EDTA means 1 mole. So 1 liter is but 1000 ml, like earlier. 1000 ml, 1 molar is equal to 100 gram. Now here, so 1 molar, 1 ml, 0.01 molar will be how much? We have divided here by 1000. This is in gram. We want it in milligram. So we have multiplied here by 10 raised to 3. So it becomes 10 raised to 5 milligram. Here we have divided by 1000. Here we will divide by 1000. So 10 raised to 5 divided by 10 raised to 3. So you will get 10 raised to 2. Here 1 molar. Here we have made it 0.01. So we have divided it by 100. So 100 milligram by 100 milligram, you will get 1 milligram. Now here Z is your 1.7. M2 is your 0.096. Find out what is B and find out what is 200 B. That is permanent hardness. Same calculation. Z is your 1.7, M2 is your 0.096, 0.096. Find out what is B. So 1.7, 1.6 into 0.096 into 1 divided by 0.01. How much is your B? How much?
1.632.
1.632. It is present in 5 ml. So in 1 liter, how much it will be? In 1 liter, how much it will be? क्या करेंगे? 5 रुपए को एक पेन है मेरे पास. I am selling one pen for 5
into 200.
To 200.
तो 1000 रुपए में मेरे पास कितने पेन आएंगे?
300.
कितने पेन आएंगे? 5 रुपए को एक पेन है, तो 1000 रुपए में मेरे को कितने पेन मिलेंगे? 200. तो यहाँ पे कितना आया आंसर बी आपका? व्हाट इज योर बी?
1.62.
1.62. 5 के लिए 1.62. तो 1000 के लिए कितना? 1.62 into 200. So कितना है?
324.
324. तो अभी इधर मोलॅरिटी कितनी है? कौस्तुभ पटकन आण माझा मोबाईल. लाईट गेलेत. कौस्तुभ पटकन आण. इथे ठेव आता आणि जा आंघोळीला जा पटकन. मॅडम 5 ते 10 दिनाने. बर इथे पटकन आपलं का? हा मॅम मला ती आतमध्ये 11 ते 12 देते. नाही तिकडे हे होऊन गेलं कोणी. Hello. There was a fall of electricity in between, so I have logged in again. So only little is left. Chalo. So what is value of strength of the EDTA, concentration of EDTA? Chalo fatafat. We have to fill this result table. Chalo 0.096. Am I audible? Am I audible?
Yes,
Yes,
ma'am.
ma'am.
Is it visible screen?
Yes,
Yes.
ma'am.
Yes, ma'am.
So what is the concentration of EDTA? 0.096.
96.
Total hardness कितना है? 744. परमानेंट हार्डनेस कितना है? ये कितना मिला आपको परमानेंट हार्डनेस आफ्टर बॉइलिंग?
324.
324.
So 744 divided by minus 324. How much is the temporary hardness? How much is the
420. 420.
420. Have you got it? How to fill the observation table? Have you understood everything? Have you understood everything? Huh?
Yes, ma'am. Yes,
Okay.
ma'am.
Okay. Now second I will share.
Yes, ma'am.
Okay. Now second I will share the only observation and calculation. I am all this what I have done it here. For the first part was standardization, for which I gave the reading 5, 5.2, 5.4. So it was 5.2 for first part. Then For total hardness, I gave you the reading 3, 3.2, 3.4. So it was 3.2. And for permanent hardness, it was 1.5, 1.7 and 1.9. So it was 1.7. So you got the strength of the EDTA 0.096. Then you got total hardness 744. You got permanent hardness 324. 744 divided minus 324, you got 420 as the temporary hardness. That is your result. This is the observation table. Huh? Yes. Any query? Any query?
Ma'am, if we find
No, ma'am.
temporary hardness in place of permanent,
Means what? Without permanent
ma'am,
hardness, how you will get temporary?
the video you send, ma'am, उसमें तो किया ना उन्होंने.
No, this is the procedure. That video is ready-made. I have not seen it clearly. Only 15 minutes I have seen it. Only you should know what is conical flask, what is burette, pipette, volumetric flask, etc. But this is the procedure. This is the procedure. First, standardization. Second, total hardness. Third, permanent. Then subtract permanent from total. You will get temporary hardness. Clear? Is it clear to everyone? Yes. Now it is already, time is done. Sorry, we do not have the time. You run it at your home. I will share the attendance sheet for you. Attendance sheet for you. There it is, actually it is for the theory, but there you write down your batch. That is practical batch, chemistry practical batch, K1 batch, put today's date and time. K1 practical batch. And many a times I have observed that you are not writing your name once, you are submitting the same form. You are submitting the same form so many times. Have you got it? Don't do it that. Don't share it that many times. This is the link for the attendance. This is the link for attendance. Are you able to see the link? Yes. Hello.
Yes, ma'am.
Fill the
Yes, ma'am.
attendance sheet. Fill the attendance sheet. Write down your roll number, all 4-digit, 5-digit completely. Write today's date. Today's date is 26/2/2021. Once you are through, just tell me, please. Are you through? Shall I end up the meeting? Shall I end up the meeting?
ये प्रैक्टिकल
Yes,
करना है.
ma'am.
Yeah.
Okay. Chalo.